Hello, my friend. Tonight I want to share a secret that physicists have quietly carried for more than 100 years. The solid, familiar world all around you, the floor beneath you, the air filling your lungs, the very light reaching your eyes in this moment, is not at all what it appears to be. Look closely enough at any piece of it, and reality begins to soften and dissolve into something far stranger, far more beautiful, and far less certain than anyone ever expected. We like to imagine that we understand the universe. We have mapped distant galaxies and split the atom into its smallest parts. And yet, at the very deepest level, almost everything is still a mystery. Why does simply looking at a particle seem to change what it does? What is the unseen substance that holds the galaxies together? Where did all of this come from, and why is there anything here at all? So let yourself grow still. Let your shoulders soften and your breathing slow. There is nothing to solve tonight, and nowhere you need to be. For the next while, we will wander gently through 20 of the deepest unsolved mysteries about reality itself. Each one stands on its own, like a small door swinging open onto the unknown. You do not need to follow a thread or hold on to anything. If you drift off somewhere along the way, that is perfectly all right. The mysteries will keep, and so will I. Let us begin. Picture a single speck of light, smaller than anything your eye could ever see, traveling alone through empty space toward a barrier with two narrow openings cut into it. Behind that barrier sits a screen, waiting to record where the speck lands. You might expect something simple. The particle goes through one opening or the other and arrives at a single spot on the screen, the way a thrown pebble passes through one gap in a fence. Send through many particles, one at a time, and you would expect two little stripes to slowly build up behind the two openings, two soft piles marking where the specks came through. But that is not what happens. Instead, as particle after particle arrives, each one alone, with long stretches of nothing in between, a pattern begins to emerge on the screen. Not two stripes, but many. Bands of brightness and darkness, evenly spaced, like ripples frozen in place on the surface of a pond. It is exactly the pattern you would see if waves had passed through both openings at once and overlapped on the far side. Some crests adding together into brightness, others meeting and canceling into shadow. This is the strange part. Each particle was sent through entirely on its own. There was no other particle for it to ripple against, no companion to interfere with. And yet, somehow, each lonely speck behaves as though it passed through both openings at the same time and interfered with itself, as if it quietly explored every possible path at once before settling onto the screen. So physicists did the obvious thing. They placed a tiny detector beside the openings, just to watch and see which one each particle truly goes through. And the moment they did, the universe seemed to change its mind. The rippling pattern vanished. The particles began arriving in two simple stripes, like ordinary pebbles after all, each one passing cleanly through a single opening, behaving themselves at last. Stop watching, and the ripples return. Watch again, and they disappear. Sit with that for a moment. The act of gaining information about the particle, of measuring which path it took, appears to reach into the experiment and reshape what the particle does. When its journey goes unobserved, it spreads out into a haze of possibility, everywhere at once. When its journey is measured, it settles into a single definite story. The world behaves one way when no one is checking, and another way the moment someone is. It helps to be clear about what is not being claimed here. This is not a matter of the particle being too delicate, so that the gentle touch of measurement merely jostles it off course. The mystery runs far deeper than clumsy fingers. The very same particle, sent under the very same conditions, weaves its pattern of possibility when its path goes unrecorded, and abandons that pattern the instant its path becomes known. Nothing seems to physically shove it. What changes is only whether the information exists somewhere in the world. The mere fact of which way being recorded appears to be enough to reshape what is real. And this is not a trick of careless equipment, nor a mistake waiting to be corrected. It has been tested countless times with light, with electrons, even with whole molecules built from hundreds of atoms. The result holds. It is one of the most carefully confirmed facts in all of science, and also one of the most baffling. So what does it mean? Here, honestly, the certainty ends and the wondering begins. Physicists agree completely on what they will see when they run the experiment. They have argued for a century about what it tells us, and they still do not agree. Some believe the particle truly has no definite location until it is measured. That possibility itself is the deepest layer of the world, and that measurement somehow freezes a single outcome into being. Some believe every possible outcome really does happen, each in its own branching version of reality, and that we simply find ourselves living in one of them. Some believe there are hidden details we have not yet discovered, quietly guiding each particle along a real path our instruments cannot yet see. These are not idle daydreams. They are serious attempts by brilliant minds to explain a result that refuses to sit still. What unsettles and what enchants is the quiet suggestion buried inside it all. That the sharp, solid world you know, where things are simply here or there, may be only a kind of surface. And just beneath that surface lies something softer and stranger, a realm of pure possibility that gently settles into the definite world only when it is touched or measured or somehow known. You are made of these very particles. Every atom in your hand, every flicker of light drifting through this room, carries this hidden double nature folded within it. And perhaps on some night long from now, we will finally understand what it means. For now, let the question rest gently in the dark. A single speck of light alone in the void, quietly being everywhere at once, until the moment the world turns to look its way. Take two tiny particles, born together in the same fleeting instant, and they can become linked in a way that has no comfortable explanation. Physicists call it entanglement. When two particles interact closely enough, their properties can become woven together, joined into a single shared state. From that moment on, they are no longer two fully separate things. They are two ends of one connected whole, even after they drift far apart. Now carry one of them away, across the room, across the country, in principle, across the entire galaxy. The two particles remain bound to each other, and here's what stops the breath. If you measure one of them and find it turning, let us say, in a particular direction, then in that very instant you know the other one will be found turning the opposite way, no matter how far it has traveled. The two outcomes are perfectly matched, every single time, as though the distant particle somehow knew what had happened to its partner the moment it happened. Einstein found this deeply troubling. He had shown that nothing in the universe can travel faster than light, that there is a strict cosmic speed limit woven into the very fabric of space and time. And yet here was something that seemed to connect two distant points instantly, with no signal passing between them, no messenger crossing the gap. He called it, with a touch of scorn, spooky action at a distance. He suspected it could not really be true. Surely, he thought, the particles must carry some secret instructions all along, agreed upon at birth, like two travelers who settled on a plan before parting ways. Then there would be nothing spooky about it at all. Just ordinary information, decided in advance and carried quietly along. For decades, this remained a matter of philosophy, a disagreement with no clear way to decide it. Then a physicist named John Bell found something extraordinary. He worked out that these two pictures of the world, the one with secret instructions and the one with genuine entanglement, would not always agree with each other. If you measured many entangled pairs in just the right way, the two ideas predicted different results. Different numbers. The question could finally be settled, not by argument, but by experiment. So the experiments were done, again and again, growing more careful and more airtight with each passing year. And nature gave her answer, clearly and consistently. Einstein's comforting picture was wrong. There are no secret instructions tucked inside the particles, no plan agreed upon in advance. The connection is real. The link between the two distant particles runs deeper than any local explanation can reach. In recent years, the scientists who proved this most rigorously were honored with the highest prize in physics for showing us that the world really is as strange as it first seemed. Now you might wonder whether this lets us send messages instantly across the stars. It does not, and the reason is subtle and quietly beautiful. When you measure your particle, the outcome you get is completely random. You cannot choose it or control it. You only discover afterward that whatever you happen to find, your partner's particle is matched to it. To anyone holding the distant particle, their own result looks like pure chance as well, until the two of you compare notes through some ordinary slower channel that obeys the cosmic speed limit. Only then does the perfect correlation reveal itself. The universe guards its speed limit with great care. It allows this strange connection, yet it does not allow you to use it to whisper across the void. So what is actually happening? What is the thread that binds the two particles, stretching across any distance without thinning, without breaking, without taking any time at all to act? Here we reach the edge of our understanding. The mathematics describes it flawlessly. We can predict the results with perfect precision. But the picture behind the mathematics, the story of what reality is truly doing, remains elusive. Some believe it means that distance itself is not as fundamental as it feels, that 2 points far apart in space may be far closer than they look in some deeper layer of the world. Some believe that the two particles were never truly separate to begin with, that our habit of seeing them as two distinct objects is itself the mistake. The honest truth is that we do not yet know. There is something quietly humbling in this. We tend to imagine the universe as a vast collection of separate things, each one sitting in its own place, touching only when they happen to meet. Entanglement whispers that this might be an illusion of our scale, that underneath, the world may be far more connected than it ever appears, stitched together in ways that pay no mind to the distances we find so impossibly vast. Two particles, once joined, forever sharing a single hidden state, speaking to each other across the emptiness in a language we can measure but cannot yet read. Let that quiet mystery settle over you now. like the faintest thread of light running silently between two distant stars. Almost everything that exists is something we cannot see. Look up on a clear night and the sky seems full. Stars beyond counting, the soft river of the Milky Way, the faint glow of galaxies impossibly far away. It feels like a great deal of universe. And yet all of it, every shining thing your eye or your telescope could ever find, makes up only a small fraction of what is truly out there. The rest, the overwhelming majority, is something else entirely. Something that gives off no light and no warmth, no signal of any kind that we have ever caught. Something we have never seen and cannot yet name. The first clues came from watching how galaxies turn. A galaxy is a vast spinning disk of stars, wheeling slowly around its center over millions upon millions of years. And here the laws of gravity, the same laws that hold you gently to the ground and swing the planets around the sun, make a clear prediction. The stars near the bright crowded middle, where most of the visible matter gathers, should orbit quickly. The stars far out at the lonely edges, with little visible matter around them, should drift more slowly, the way the outer planets circle the sun, far more lazily than the inner ones. But that is not what the galaxies do. When astronomers measured the speed of stars way out at the edges, they found them racing along just as fast as the stars deeper in. The galaxies were spinning too quickly at their rims. By every rule we know, they should be flying apart, flinging their outer stars off into the dark like a carousel spun far too fast. And yet they hold together, calm and whole, as they have for billions of years. Something is holding them, some great unseen mass wrapped all around each galaxy in a vast invisible halo, far larger and far heavier than all the stars within it. Its gravity grips the outer stars and keeps them from escaping into the night. We cannot see this mass. We can only feel its pull, written into the motion of everything we can see. And the evidence did not stop there. We see the same thing in the way whole clusters of galaxies move, far too fast to stay bound together by their visible matter alone. We see it in the way light from distant galaxies bends as it passes by, curving around great hidden clumps of mass like a stream flowing around stones beneath the surface. Everywhere astronomers look, on the largest scales, they find the very same story. There is far more gravity in the universe than there is visible stuff to account for it. The missing ingredient came to be called dark matter, not because it is black, but because it is unseen, perfectly transparent to light, revealing itself only through its weight. And there is a great deal of it. For every gram of ordinary matter in the cosmos, the kind that builds stars and planets and your own body, there appears to be several grams of this dark, unknown substance. It outweighs everything familiar by a wide margin. It forms an invisible scaffolding threaded through all of space, and along that scaffolding the visible galaxies first gathered and grew, like dew collecting along the strands of an unseen web. Without it, the universe as we know it might never have come together at all. So what is it? This is where the honest answer becomes a quiet confession. We do not know. We have searched with enormous care. Deep underground, shielded from the noise of the surface world, physicists have built exquisitely sensitive detectors and waited in the silence for a single particle of dark matter to drift through and gently nudge an atom. We have hunted for it inside the great machines that smash particles together, hoping to conjure a flicker of it ourselves. We have scanned the sky for any faint trace it might leave behind. And so far, it has stayed hidden. We know it is there with great confidence because we can feel its gravity stretching across the entire cosmos. But what it is made of, what kind of thing it truly is, remains one of the deepest unsolved puzzles in all of science. There is a strange and beautiful humility in this. We walk through the world feeling sure that we can see what surrounds us, that the lit and solid things are the real things. And then we learn that the visible universe, all the stars and galaxies and glowing clouds we have ever admired, is only the thin, bright foam riding on the surface of a vast, dark sea. The greater part of creation moves around us unseen, holding the galaxies together in its quiet hands, and we have not yet learned its name. Tonight, as you rest, picture the galaxy you live within, that great slow wheel of stars turning in the dark. And picture, wrapped all around it, far wider than the stars themselves, an invisible cloud cradling it gently together, unseen, unknown, and everywhere at once. Let that vast, quiet presence hold you too, as you drift softly towards sleep. The emptiness between the galaxies is growing, and it is growing faster every single day. For most of the last century, astronomers knew that the universe was expanding. Long ago, everything was packed together unimaginably close. Then came the great beginning we call the Big Bang. And ever since, space itself has been stretching, carrying the galaxies away from one another like raisins drifting apart in a slowly rising loaf of bread. This alone was already a wondrous idea. The space between things is not a fixed and empty stage. It swells, it grows. The distances in the cosmos are quietly increasing all the time. Now, everyone fully expected this expansion to be slowing down. It made perfect sense. All the matter in the universe pulls on all the other matter through gravity, drawing everything inward. So the outward rush from the Big Bang should be gradually losing speed, like a ball thrown up into the air, rising more and more slowly as the Earth tugs it back home. The only real question, astronomers thought, was whether gravity would one day win and pull everything back together, or whether the expansion would simply coast onward forever, growing slower and slower with each passing age. So in the final years of the last century, two teams of astronomers set out to measure the slowing. They studied the light of distant, exploding stars, far across the cosmos, whose brightness let them gauge enormous distances with remarkable care. By gazing deep into space, they were also gazing deep into the past, seeing the universe as it had been billions of years ago. They expected to find that the expansion back then was faster than it is now, the clear signature of a cosmos gently applying its brakes. What they found instead overturned everything. The distant explosions were dimmer than they should have been, which meant they were farther away than anyone had expected. The expansion had not been slowing down at all. It had been speeding up. For billions of years now, the galaxies have been racing apart faster and faster, the empty space between them widening at an ever-quickening pace. Both teams found the same impossible result, and checked it again, and could not make it go away. Something is pushing the universe apart. Something is overpowering the inward pull of all the matter in existence and driving everything outward with growing force. It fills all of space, even the most perfect emptiness you could imagine. It has no glow and casts no shadow. We gave it a name to hold our ignorance, and we called it dark energy. And it is not some minor detail. When physicists add up everything in the cosmos, they find that this dark energy is by far the largest part of it. Roughly 2/3 of all the energy in the universe seems to be this strange pushing force, woven silently into empty space itself. The ordinary matter that makes the stars and planets, and even the unseen dark matter that holds the galaxies together, are together only the lesser share. The single greatest ingredient in all of reality is something we discovered almost by accident and still cannot explain. What could it possibly be? One old idea, written down long ago and then set aside, is that empty space is not truly empty, that the vacuum itself carries a faint and ceaseless energy, a gentle pressure pushing outward everywhere at once. It is an elegant thought. But when physicists try to calculate how strong this energy of empty space ought to be, their answer comes out staggeringly, almost absurdly wrong, larger than what we actually observe by a number so vast it is nearly impossible to write down. Something is missing from our understanding, something deep, and we do not yet know what it is. There is a quiet weight to where all of this is leading. If the expansion keeps accelerating, then far in the future, the galaxies will be carried so far apart, so fast, that their light will no longer be able to reach one another. A being living in some distant age might look up into an almost empty sky with nearly every other galaxy long since swept beyond view, and have no way of ever knowing that the wider universe had once been there at all. The cosmos is slowly, gently scattering itself, growing lonelier across spans of time too immense for the mind to truly hold. But that is the far distant future, and not tonight. Tonight the sky is still full, and the galaxies still shine, and the great mysterious force flows quietly on, doing its patient work in the dark between the stars. Let yourself rest now in that vast, slow stretching of space, a universe gently widening all around you, carried outward by something nameless, opening into an immensity we have only just begun to understand. You can remember the past, but never the future. It seems almost too obvious to question. Of course, time moves forward. Of course, we recall what has already happened and never what is yet to come. The past feels fixed and finished, the future open and unwritten. A cup slips from the table and shatters on the floor, and it never gathers its pieces back together and leaps up into your waiting hand. Time flows in one direction only, like a river, always onward, never back. And yet, when physicists look closely at the deepest laws of nature, they find something astonishing hidden inside them. Almost all of those laws work exactly the same whether time runs forward or backward. The rules that govern a moving particle, two balls colliding, light traveling through empty space, the gentle pull of gravity between distant worlds, none of them seem to care which way time is pointing. Run them forward, and they describe what happens. Run them in reverse, and they describe something equally aloud. At the level of single particles, a film of events played backward would look perfectly natural, breaking no law at all. So where does the forward flow of time come from? Why, if the basic rules are blind to direction, does the world we actually live in have such a clear and unbreakable arrow? Why does the cup shatter but never gather itself whole again? Why do we grow older and never younger? Why does the past feel so utterly different from the future? The deepest clue we have rests in a single quiet idea. In any group of things left to itself, disorder tends to increase. A neat arrangement is easy to disturb and hard to restore. There are countless ways for a thing to be jumbled, and only a precious few ways for it to be tidy. So as time passes, order tends to slip toward disorder, simply because disorder is so much more likely to stumble into. Physicists measure this gradual drift toward disorder and call it entropy. And they have found that in the universe as a whole, it almost always grows. The shattered cup is a more disordered thing than the whole one, and its pieces scattered across the floor are more disordered still. The direction in which disorder increases is the very direction we have come to call the future. This is a beautiful answer, and it explains a great deal, but it carries within it a far stranger question. If disorder is always increasing as time moves forward, then it must have been lower in the past, and lower still further back, all the way to the very beginning, which means the universe must have started in a state of extraordinary order, almost unimaginably neat and smooth, near the moment of the Big Bang, and no one knows why. Why did the universe begin in such a special, orderly condition when there were so many more disorderly ways for it to have started? This is one of the great unsolved puzzles, and the whole arrow of time, the entire difference between past and future, seems to rest delicately upon it. Sit for a moment with how strange this is. The reason the cup will not reassemble on your table tonight, the reason your memories run backward into the past and never forward into the future, the reason you feel time carrying you gently from what was toward what will be, may trace all the way back to the peculiar tidiness of the infant universe nearly 14 billion years ago. The forward flow of every moment you have ever lived may be a long, quiet echo of how everything began. And there is something deeper still that we cannot fully grasp. The forward feel of time, the vivid sense that this present moment is real and moving, that the past is gone and the future has not yet arrived, is so central to our experience that we can scarcely imagine being without it. Yet nowhere in the fundamental equations of physics does this flowing present appear. The laws describe a kind of unchanging landscape of all moments, past and future, laid out together, with no special marker for now. Why we experience time as a moving stream rather than a still and finished map is a mystery that touches both physics and the nature of the mind itself, and it remains unsolved. So the river of time flows on, carrying you along with it, and we still do not fully understand its source, or why it runs the way it does, or even whether its flowing is a feature of the world or a feature of us. For now, simply let it carry you. Let this moment soften into the next, and that one into the one after, gently, without effort, the way the night drifts quietly toward morning. There is no need to hold on to any of it. Time will do what it has always done and bear you kindly onward into sleep. Trace everything back far enough, and the entire universe shrinks down to something smaller than you could ever imagine. Take the galaxies racing apart tonight and run the great expansion backward in your mind. The galaxies draw closer together. The space between them shrinks. Go back further, billions upon billions of years, and everything grows hotter and denser and more tightly packed, the whole cosmos contracting toward a single searing instant. Go back as far as we possibly can, and we arrive at a moment, nearly 14 billion years ago, when all that would ever become stars and planets and people was gathered into a state of almost unthinkable heat and density. We call that beginning the Big Bang. It is a humble little name for the origin of absolutely everything, and it is easy to picture it wrongly as a great explosion going off somewhere in the middle of empty space. But that is not quite right. There was no surrounding space for it to explode into. Space itself was part of what was tightly furled up in that beginning, and the expansion was not things flying apart through space, but space itself unfurling and stretching everywhere at once. The Big Bang did not happen at a single point within the universe. In a sense, it happened everywhere, because everywhere was once that single point. We have real evidence that this beginning truly was. There's a faint afterglow still bathing the whole sky in every direction, a whisper of warmth left over from when the universe was young and glowing, now stretched and cooled by all the long eons of expansion into a soft hum of light we can detect with our instruments. We can read in it the conditions of the early cosmos with remarkable precision. The Big Bang is not merely a guess. It is one of the best supported ideas in all of science, written quietly across the entire sky. But here's where our knowledge reaches its furthest edge, and the great question begins. What came before? What happened in that very first instant? And what, if anything, came before it? Here we must speak carefully and mark clearly the boundary between what we know and what we only wonder. As we trace the universe back toward that first moment, our finest theories begin to falter. The laws we trust break down. The numbers stretch toward the impossible. We cannot yet see all the way to the very beginning, because we do not yet have a theory that works in those extreme conditions, where the whole universe was smaller than a single atom and the rules of the very large and the very small crash together. So the honest truth is that the first instant itself and anything before it lies beyond our current understanding. That has not stopped us from wondering, and some of the wondering has taken the shape of serious theory, carefully labeled as such. Some physicists suspect that in its first sliver of a second, the universe went through a burst of staggeringly rapid growth, swelling unimaginably in less than the blink of an eye, and that this could explain why the cosmos looks so smooth and even across vast distances today. This idea fits a number of our observations well, but it remains a theory, not a settled fact, and the finer details are still debated. Others wonder whether our Big Bang was truly the beginning at all, or whether it might have been one chapter in some far longer story. Perhaps a universe that expands and contracts in great slow cycles, or a single bubble among countless others in a vaster reality forever hidden from our view. These are imaginative ideas, reaching out beyond the edge of evidence, and they are offered as possibilities, not as truths we have confirmed. And then there is the strangest question of all, the one that makes the mind go quiet. Did time itself have a beginning? If time began together with the universe, then asking what came before the Big Bang might be a little like asking what lies north of the North Pole. The question may simply have no answer, not because we are not clever enough, but because there may be no before for there to be. There may have been no earlier moment, no empty waiting, no ticking clock in the dark, just the beginning with nothing prior to it, including no time in which a prior could even exist. It is nearly impossible to truly picture, and we do not know if it is so. How wondrous and how humbling to live inside something whose beginning we can almost reach out and touch, yet never quite grasp. To know that everything around you, every atom of you, traces back to a single brilliant instant, and to stand at the very edge of that instant and find the deepest question of all still waiting there, unanswered in the dark. Let that great quiet sit with you now. The whole universe, you and the stars alike, born together from one unfathomable beginning, the first moment of all moments, still keeping its oldest secret. Rest there at the edge of the beginning and let yourself gently drift. At this very moment, there is something it is like to be you. You are hearing this voice. Perhaps you feel the soft weight of a blanket, the warmth of the room around you, the slow drift of your own thoughts as you begin to settle. There is an inner world here, a felt experience, a quiet sense of what it is like to be you right now, tonight. It is the most obvious thing in all of existence. It is the one thing you can be absolutely certain of, and it may be the single deepest mystery in the entire universe. Here is the puzzle. As far as we can tell, you are made of ordinary matter. Inside your skull sits the brain, a vast and intricate web of cells, nearly 100 billion of them, passing tiny pulses of electricity and faint chemical signals between one another in patterns of breathtaking complexity. We can study this. We can watch it work. When you see the color red, certain cells in your brain grow active. When you feel afraid, or remember a face, or taste something sweet, we can find the flickers of activity that go along with it. We have learned a great deal about which parts of the brain do which kinds of work, and the picture grows a little clearer every year. But all of that is the machinery. All of that is matter in motion, signals and cells, the physical dance of the brain. And here's the question that no one can yet answer. Why is any of it accompanied by an inner experience at all? Why is there something it is like to be that web of cells? Why does the activity in your brain not simply happen silently in the dark, the way the chemistry in a stone or the currents in a machine presumably happen, with no one home to feel any of it? Why is there the warm felt experience of red, rather than only the brain quietly registering a wavelength of light and responding? Why is there a someone here looking out from behind your eyes? This is what thinkers have come to call the hard problem. We can imagine, at least in principle, explaining all the workings of the brain, every signal, every behavior, every word you speak, purely in terms of physical cause and effect. And even if we managed it completely, we would still not have explained why all that machinery feels like anything at all from the inside. The gap between the physical story and the felt experience seems to be of an entirely different kind. You can describe every last detail of how the eye and brain process light, and nowhere in that description does the actual experience of seeing ever appear. It is as though something has been quietly left out, something we cannot quite point to, and yet it is the only part we know for certain is there. Nobody knows how to close this gap. It is not simply that we are waiting on a better brain scanner or a few more years of patient research, though those will surely teach us a great deal. The difficulty runs deeper than that. We do not even fully understand what kind of answer we are looking for. How could mere matter, arranged in any pattern however clever, give rise to the warm felt presence of an inner life? Some thinkers suspect that experience somehow emerges when matter is organized in just the right way, though no one can yet say how or why. Some wonder whether a faint trace of experience might be woven into the very fabric of the world, present in some dim form, even in the simplest things, an old and serious idea that is impossible to prove and surprisingly hard to dismiss. Some suspect we are missing a piece of the puzzle, so basic that we cannot yet even imagine its shape. All of these are offered honestly as attempts, not as answers. The truth is that the relationship between the physical brain and conscious experience remains one of the great open questions, perhaps the very deepest of them all. And the strangeness only grows when you turn it upon yourself. The very thing wondering about this mystery is itself the mystery. The awareness hearing these words is the unexplained thing. You are not standing safely outside the puzzle, looking in. You are the puzzle, looking out. The universe, through you, has somehow come to be aware of itself, to feel and to wonder and to ask why it feels at all, and how this came to be, no one can say. There is a quiet wonder in simply noticing it. That behind your eyes in this very moment, a small piece of the cosmos is awake and aware, having an experience that no instrument can measure and no theory can yet explain. The most familiar thing in your whole life, the simple fact of being here, of there being a someone home, is also the most profound unsolved riddle we have ever encountered. You do not need to solve it tonight. You only need to rest gently within it. Let the wondering grow soft. Let the awareness that has carried you through this whole long day begin slowly to dim towards sleep. The inner light lowering like a lamp turned gently down, still glowing, still here, still quietly aware, as you drift away into the dark. There could have been nothing at all. No stars, no galaxies, no light, no space for any of it to fill. No you lying here in the quiet, no world to lie in. Not even darkness, for darkness is still something, and emptiness waiting. Just nothing. No things, no laws, no time, no place. It is almost impossible to truly picture, because the moment you try, you are already imagining a kind of empty stage, and even an empty stage is something. But set that difficulty gently aside for a moment, and let the question land in its full weight. There could have been nothing whatsoever. And yet, here is all of this. Here is everything. Why? This may be the oldest question a mind has ever asked, and also the simplest and also the deepest. Why is there something rather than nothing? Why does the universe bother to exist at all? Physics has given us astonishing answers to a great many questions. We can describe how stars are born and how they die. We can trace the path of light across billions of years. We can write down in elegant equations the rules that the particles and forces seem to obey. But notice what all of those answers quietly have in common. Every one of them describes how something behaves, given that it already exists. Each explanation reaches back to some earlier thing, some prior law, some starting condition. The star formed from a cloud of gas. The gas was left over from the early universe. The early universe unfolded according to certain rules, and so on, back and back. But this long chain of explanation, however far we follow it, always assumes that there is already a something there to be explained. It never quite reaches the very bottom. It never tells us why there is a chain at all. You can feel the strangeness if you keep on asking. Suppose we one day discover the deepest law of nature, the final rule from which everything else flows. A beautiful equation, perhaps simple enough to write upon a single page. We would have explained a great deal, but we could still turn to that equation and ask softly, why this law and not some other? Why should any law hold sway at all? Why should there be rules and things for the rules to govern, rather than simply nothing? The deepest law, if we ever find it, would still sit there unexplained, existing for no reason we can point to. Some thinkers have wondered whether nothingness might be unstable, whether a perfect nothing could not hold itself together, and would somehow tip over into something all on its own. There are hints in the strange mathematics of the very small that what we call empty space is not as quiet or as simple as it first seems. And a few physicists have asked whether a universe could emerge from a kind of emptiness through the restless rules of that realm. These are serious and fascinating ideas, and they are worth holding gently. But we must be honest about what they are. Even if a universe could arise from some quantum emptiness, that emptiness is already a something. It already comes with rules, with possibilities, with a stage on which the arising can happen. The very deepest form of the question slips past all of this and asks why there should be any rules, any possibility, any stage, rather than nothing whatsoever. And to that, no one has an answer. It may lie forever at the quiet edge where physics meets philosophy, a question we can ask with perfect clarity and may never be able to close. And yet here you are. Not nothing. Something. A warm, breathing, wondering something, lying in the dark, made of atoms forged in the hearts of long-dead stars, looking out at a universe that did not have to be here at all and asking why it is. There is a quiet kind of awe in that, deeper than any answer could ever give. You are a small piece of the something that exists in place of nothing. The very fact that you can wonder about this at all, that there is a you here to do the wondering, is itself part of the great, improbable fact of there being anything. Whatever the reason, if there is a reason, the universe leaned toward existence. And it carried that leaning all the way down to this moment, to this breath, to you. So you do not need to answer it tonight. No one ever has. You only need to feel for a moment the gentle wonder of being here at all, of being something rather than nothing, a small lit candle of existence in the vast and quiet dark. Rest in that simple, astonishing fact. There is something, and you are part of it. Let that be enough, and let yourself drift. The universe seems to be balanced on the edge of a knife. Hidden inside the laws of physics are a handful of plain numbers. The strength of gravity, the strength of the force that binds the hearts of atoms together, the masses of the tiny particles that make up everything. These numbers are not things we can calculate or explain from any deeper principle, at least not yet. We simply measure them, the way you might read the settings on a great machine we did not build. And here's the quietly astonishing thing. If you were to reach in and change almost any one of these numbers, even by a tiny amount, the universe that resulted would be barren. No stars, no atoms, no chemistry, no life of any kind. Nothing to admire it, and no one to be. Consider the force that holds the centers of atoms together. Make it just slightly stronger or slightly weaker, and the simplest atoms could not form properly, and the stars could not forge the heavier elements that you are made of. Carbon, the very backbone of all life we know, would never come to exist in any useful amount. Or consider gravity itself. If it were much stronger, stars would burn through their fuel in a furious rush and die long before life could ever take hold. If it were much weaker, the gas of the early universe might never have gathered into stars at all, and the cosmos would drift on as a thin, cold haze, dark and empty forever. Again and again, when physicists explore these what-if universes on paper, they find the same haunting result. The settings that actually hold in our world sit within a narrow band that allows complexity and structure and eventually living things. Step outside that band, and you get a universe where nothing interesting can ever happen. Sit for a moment with how strange this is. Of all the values these numbers could have taken, Why do they fall so precisely within the slim window that allows stars to shine and atoms to bond, and a being like you to one day wake and wonder about it? It can feel almost like walking into a vast control room filled with countless dials and finding every single one turned to exactly the setting needed for life, as though someone had been there before us, carefully adjusting each one in turn. This is what physicists call the fine-tuning of the universe, and it is a genuine puzzle, taken seriously by serious people. But what it means is very much an open question, and here we must tread carefully, marking clearly where solid ground ends and speculation begins. One idea, offered as a theory and not as a settled truth, is that our universe may be only one among an unimaginable many. Perhaps there's a vast collection of universes, each with its own roll of the dials, its own set of these fundamental numbers, most of them barren and lifeless. In such a picture, it would be no surprise that we find ourselves in one of the rare universes where the numbers happen to allow life, because we could only ever exist in such a place. A being can only ever find itself in a universe capable of producing beings. This is a fascinating thought, and it follows rather naturally from some of our other theories. But it remains unproven. We have no way, at present, to see these other universes, or to confirm that they are truly there at all. It is a possibility gently held, not a fact established. Other thinkers wonder whether there might be some deeper law we have not yet discovered, a hidden principle that fixes these numbers and forces them to take the values they have, so that they only appear finely tuned because we do not yet understand what determines them. In that case, the fine balance would not be luck or design at all, but quiet necessity, a single deep truth wearing the mask of coincidence. This too is a real possibility, and it too remains unproven. The honest answer, once again, is that we do not yet know why the universe is built so finely for its own richness. What stays with you, beneath all the careful uncertainty, is the sheer delicacy of it. That the floor beneath you, the warmth of the distant stars, the carbon in your blood and the air in your lungs, all of it rests upon a handful of numbers that could so easily have been otherwise. And that happened, for reasons we cannot yet name, to allow a universe gentle enough and rich enough for you to exist within it and look up and notice. Perhaps it is luck on a scale beyond all imagining. Perhaps it is a necessity we have not yet uncovered. Perhaps it is something we have not yet learned how to dream. We do not know. But tonight, you do not need to know. You only need to feel, softly, the wonder of living in a universe so finely balanced that your very existence depends upon it. A cosmos delicately poised to allow this quiet moment, this breath, this slow drifting towards sleep beneath a sky full of stars that did not have to shine. Rest there, on that gentle knife's edge, held by numbers no one can yet explain. For every kind of particle in the universe, there is a mirror twin that can erase it. This is not a fancy or a figure of speech. It is a real feature of nature, confirmed countless times in laboratories around the world. Alongside the ordinary matter that makes up everything you know, there exists a shadow version of it called antimatter. For each tiny particle of ordinary matter, there is an antiparticle, identical in almost every way, yet opposite, as though reflected in some deep and perfect mirror. And when a particle of matter meets its antimatter twin, something dramatic happens. They annihilate each other completely, both vanishing in a flash of pure energy, a tiny burst of light. Nothing solid is left behind. The two opposites cancel, and where they once were, there is only a fading glow. We are not guessing about any of this. We make antimatter ourselves, in small amounts, in the great machines where particles are smashed together. It appears briefly inside certain kinds of medical scanners that doctors use to peer gently into the body. Antimatter is as real as the bed you are lying in. It simply does not last long in our world, because our world is made of matter, and the moment a speck of antimatter touches ordinary matter, the two destroy each other and are gone. Now here is where the deep mystery quietly opens. When we look back to the very beginning of the universe, to the searing first moments after the Big Bang, our best understanding says that matter and antimatter should have been created in equal amounts. For every particle, an antiparticle, a perfect balance, a cosmos with exactly as much matter as antimatter, the two born together in equal measure out of the raw energy of the young universe. But if that were truly so, then something final and complete should have happened next. All that matter and all that antimatter, made in equal parts, should have found each other and annihilated, particle meeting antiparticle, twin canceling twin, until almost nothing remained but a universe flooded with light. No leftover matter. No galaxies, no stars, no planets, no atoms, no you. Just a vast bath of gently cooling radiation, drifting forever in the dark. By the simplest reckoning, the universe should be empty of everything except light. And yet, look around. Here are the stars, here are the galaxies, here is the earth and the air, and your own hands resting quietly in the dark. The universe is full of matter, built from the particles that somehow were not annihilated. Something tipped the balance. Somehow, in those first moments, there came to be a little more matter than antimatter. Only the faintest bit more, perhaps one extra particle of matter for every billion matched pairs. But it was enough. The matter and antimatter mostly destroyed each other, just as expected, flooding the early universe with light. And when that great annihilation was finally over, that tiny surplus of matter was all that remained. That faint leftover, that 1 part in a billion, became every galaxy, every star, every living thing. It became you. So what tipped the scales? Why was there a little more matter than antimatter, when our deepest principles suggest there should have been precisely the same amount of each? This is one of the great unsolved questions in physics, and it carries a quiet weight, because the answer is the reason there is anything at all, rather than only light. Physicists have found a few tiny hints that matter and antimatter do not behave in perfectly mirror-identical ways, that there are subtle differences in how certain particles and their twins fade and decay. But the differences we have measured so far are far too small to explain the imbalance we actually see. Something else, some deeper asymmetry written into the dawn of the universe, must have been at work. We have not yet found it. We know it must be there because we are here to wonder about it, yet its true nature remains hidden. There is something humbling and strangely intimate in this. Every atom in your body, every particle that makes you who you are, is a kind of survivor. It comes from that vanishingly thin sliver of matter that escaped the great annihilation at the beginning of time, the 1 part in a billion that was left standing when its mirror twin was already gone. The overwhelming majority of what the early universe created destroyed itself in those first moments and dissolved into light. You are made from the remainder. You are made from what was left when the mirror emptied. How quiet and how astonishing to be built from the tiniest imbalance at the beginning of everything, a survivor of a silent reckoning between matter and its shadow that was over before the first star ever shone. Tonight, as you settle into the dark, you can hold that gently. You are here because, for reasons no one yet fully understands, the universe kept just a little more than it let go. Rest in that small surplus of being, that faint leftover light made solid, then let yourself drift softly towards sleep. A single particle can hold two opposite states at the very same time. In the everyday world, things are one way or another. A coin lies heads or tails. A door is open or shut. A light is on or off. We never see a coin that is somehow both faces at once, or a door that is open and closed together. Our world is made of definite things, each one settled into a single clear condition. But down in the realm of the very small, this comfortable rule quietly dissolves. A tiny particle can spin in one direction or in the other. That much sounds ordinary enough. But before you measure it, the particle does not have to choose. It can exist in a strange blend of both possibilities at once, spinning one way and the other way at the same time, held in a kind of shimmering mixture that has no everyday picture. Physicists call this a superposition. And it is not that the particle is secretly spinning one definite way, and we simply do not know which. The mathematics and the experiments tell us something far stranger. The particle truly is in both states together, a living blend of possibilities, right up until the moment it is measured. Only then does it settle, all at once, into a single definite answer, one direction or the other, as though the very act of looking forces it to finally decide. This is one of the most thoroughly tested ideas in all of science. We rely upon it completely. The behavior of superposition lies at the heart of how atoms hold together, how certain materials carry electricity, how the newest and strangest computers are beginning to be built. It is woven into the fabric of the small world, as real as anything we know. And yet it remains deeply, almost unbearably mysterious because of one simple and haunting question. Where does the small world end and the everyday world begin? A physicist named Erwin Schrödinger once dreamed up a thought experiment to lay this strangeness bare, and it has haunted the field ever since. Imagine, he said, a cat sealed inside a box. Inside the box is a single tiny particle of the kind that can exist in a superposition, poised between two states. And the box is arranged so that one of those states would, through a chain of events, release something harmful to the cat, while the other state would leave the cat safe and well. Now close the box and wait. The particle, unmeasured, drifts into its superposition, both states at once. But the particle's two states are tied to the cat's fate. So if we take the mathematics at its plain word, the cat too should fall into a superposition. Both fates at once, the safe one and the other, held together in an impossible blend until someone opens the box and looks. Now, Schrödinger did not mean this as a true prediction about cats. He meant it as a kind of gentle alarm bell. Of course, we never open a box and find a cat hovering in some blurred mixture of two fates. We always find a single, definite cat in one clear condition. The cat is far too large, far too warm, far too tangled up with the air and the box and the whole wide world around it to hover in a delicate superposition. The shimmering blend collapses almost instantly at that scale, faster than thought, into a single ordinary reality. And yet the thought experiment points its quiet finger right at the heart of the puzzle. The tiny particle can truly be in both states at once. The cat cannot. So where exactly is the line? At what size? At what point along the long path from a single particle to a living cat does the strange both at once world give way to the definite either-or world we live in? What counts as a measurement, the thing that forces possibility to settle into solid fact? This is the deep, open question, and physicists do not agree on the answer. Some believe the superposition never truly collapses at all, and that every possibility goes on quietly existing, the world itself branching so that each outcome happens somewhere. Some believe there is a real and definite collapse, perhaps triggered when enough of the world becomes involved, though no one can yet say precisely how or where or why. We have learned to predict, with flawless accuracy, what we will measure. We have not learned what is truly happening in the moment. A blur of possibility becomes a single solid fact. The line between the two worlds is one of the great unsolved mysteries, hiding in plain sight inside the most ordinary moment of looking. There is a soft wonder in carrying this thought with you. The solid, settled world you live in, where things are simply one way or another, may rest upon a deeper layer where things hover gently between all their possibilities, waiting. Every particle in your body can, in principle, hold many states at once. It is only in their countless togetherness, in the warm, dense weave of you, that the shimmer settles into the single steady reality of a person resting in the dark. So let the question lie quietly beside you tonight. A tiny thing, somewhere, spinning both ways at once in the dark, holding all its possibilities open, the way the world itself seems to hold its breath in the moment before each moment becomes real. Let it rest, and let yourself rest with it gently, all the way towards sleep. Our two greatest descriptions of reality flatly contradict each other. Over the last 100 years, physics built two towering achievements, two theories so successful, so precisely confirmed, that they stand among the finest things the human mind has ever made. Each one describes the world with breathtaking accuracy. Each one has been tested again and again and never once been found wrong. And yet, deep down, the two of them tell stories about reality that simply cannot both be true. They are like two flawless maps of the same land that quietly disagree about its very shape. The first is the theory of the very large. It describes gravity and space and time on the grand scale of planets and stars and galaxies. In this picture, space and time are smooth and flowing, woven together into a single gentle fabric. Massive things like stars and planets press down into that fabric and curve it, the way a heavy ball would dimple a stretched sheet, and the curving of space is what we feel as gravity. The Earth circles the sun, not because of any pull on a string, but because it is gliding along a valley in the curved shape of space itself. This theory paints reality as graceful and continuous, a flowing landscape that bends and ripples, orderly and serene. And it has passed every test we have ever devised, guiding our spacecraft across the solar system and correctly predicting the faint ripples that spread through space when distant black holes collide. The second is the theory of the very small. It describes the world of atoms and the tiny particles within them. And down there, reality wears an utterly different face. Nothing is smooth and nothing is certain. Particles flicker and jump. They hold many possibilities at once and settle into one only when they are measured. The tiny world is grainy, restless, and ruled by chance rather than by graceful certainty. This theory, too, has passed every test, predicting the behavior of matter and light with a precision so exact it is almost beyond belief. It underlies very nearly all of our modern technology. It is, by some measures, the most successful theory ever written down. So we have one theory for the very large, smooth and flowing and orderly, and another for the very small, grainy and jittery and ruled by chance. And for most purposes, this causes no trouble at all, because the two domains rarely meet. Gravity is far too weak to matter for a single tiny particle, and the strangeness of the small world averages quietly away long before you reach the scale of planets. Each theory rules its own country in peace, and we simply use whichever one fits the question before us. But there are places in the universe where the very large and the very small are forced together, where something enormously heavy is also crushed down to a vanishingly tiny size. The center of a black hole, where the corpse of a giant star is squeezed toward a single point. The very first instant of the universe, when everything that exists was packed smaller than an atom. In those extreme places, you need both theories at the very same time. You need to describe something both immensely heavy and unimaginably small, where gravity and the quantum world cannot be kept apart. And when physicists try to do exactly that, to bring the two great theories together and ask what happens, the mathematics breaks down. The equations give nonsense. They produce infinities, answers that mean the theory has reached the limit of its understanding and can go no further. The two finest descriptions of reality we possess simply refuse to be joined. This is the great unfinished task at the very heart of physics. We do not yet have a single theory that can describe both the very large and the very small at once, a deeper picture beneath the two from which both of them would flow. We call the missing piece a theory of quantum gravity, and finding it has resisted the most brilliant minds for the better part of a century. There are bold attempts, and it is worth being honest about exactly where they stand. One famous idea imagines that the smallest pieces of reality are not points at all, but tiny vibrating threads, and that everything in existence arises from their music. Another imagines that space itself is not smooth but woven from tiny indivisible grains, a fabric with a finest possible weave. These are serious, beautiful, deeply worked out ideas, pursued by gifted people for decades. But it must be said plainly that none of them has yet been confirmed by any experiment. They remain candidate theories, possible glimpses of the deeper truth, and not the answer itself. We are still searching for the one description of reality that holds true everywhere, in the largest and the smallest things alike. There is something quietly stirring in this. It means that the universe, at its very deepest level, is still hidden from us. We hold two magnificent maps, each one flawless in its own country, and we have not yet found the single greater map of which they are both only pieces. Somewhere beneath the smooth flowing space of the stars and the restless grainy dance of the atoms, there is a deeper reality we have not yet learned to see, waiting patiently for us to find the words for it. For tonight, you can simply let that mystery rest. The world is stranger and deeper than our finest theories can yet hold, and that is not a cause for worry, but a soft and open wonder. There is still so much waiting to be understood, and the universe keeps its deepest secret gently, in no hurry to be known. Rest there in the vast unfinished mystery of it, and let yourself drift towards sleep. Empty space is not truly empty. Imagine the emptiest place you possibly can. Not the air of a quiet room, which is thick with countless drifting molecules, but a true and perfect void. Take a sealed box and remove every speck of matter from inside it. Pump out all the air, every last atom, every particle of dust. Shield it from all light and all radiation. Cool it down toward the very coldest temperature that nature allows. What is left inside, you might think, is nothing at all. Perfect emptiness, a pure and silent void, still and featureless, holding nothing whatsoever. But that is not what the deepest physics tells us. According to our finest understanding of the small-scale world, that perfect emptiness is not still, and it is not silent. It quietly seethes. Down at the smallest scales, in what should be utterly empty space, tiny particles are ceaselessly flickering into being and vanishing again, appearing in fleeting pairs and dissolving back into nothing almost before they exist. The void churns with a restless, ghostly activity, a constant faint boiling of particles too short-lived to ever catch and hold, winking in and out faster than any clock could ever mark. The emptiness is alive with a soft and ceaseless trembling, never quite at rest, never truly still. This sounds like the wildest kind of fantasy. How could anyone possibly know that empty space behaves this way, when these flickering particles vanish far too quickly to ever be caught? And yet, we have measured its effects, gently and unmistakably. Here's the most beautiful demonstration of all. Take two perfectly smooth plates and place them extremely close together, facing each other in the void, almost but not quite touching. The restless trembling of empty space presses upon them from every side, but in the narrow gap between the two plates, only some of that trembling can fit, while outside them, the full restlessness of the void presses in. The result is a faint but real imbalance, a gentle pressure pushing the two plates together, arising from nothing at all but the seething of the empty space around them. This delicate push has been measured in the laboratory, exactly as predicted. The emptiness, it turns out, can exert a force. Nothing can push upon something. The void leans quietly on the world. Sit with that for a moment. The most perfect emptiness you could ever make is not a quiet absence, but a quiet presence. A humming, trembling sea that fills all of space, even the space inside your own body, even the vast dark reaches between the stars. There is no true nothing anywhere. Beneath the very floor of reality, there is always this faint, restless shimmer, the lowest possible state of the world. And even at its very lowest, it is never wholly silent. And here the deep mystery opens. If even empty space carries this ceaseless trembling, then empty space must carry energy, the energy of all that flickering and stirring. So physicists tried to calculate how much energy is held within the emptiness, how much this restless shimmer of the void should weigh when you add it all up. And the answer that comes out of our theories is one of the strangest and most troubling numbers in all of science. By the most natural reckoning, the energy of empty space should be enormous, almost unimaginably vast. Yet when we look at the actual universe and measure the true energy of the emptiness, we find it is extraordinarily small, fainter than our calculation by a margin so staggering it is hard to even express in words. Our best theory of the trembling void and our actual measurement of it disagree by one of the largest gaps between prediction and reality ever found. Something is deeply missing from our understanding of what the emptiness truly is and what it holds, and no one yet knows what. There's a quiet awe in this, deeper even than the puzzle itself. We tend to think of nothingness as simple, as the easy default, the plain blank backdrop against which all the interesting things happen. And then we look closely and discover that nothing may be the most mysterious thing of all. That the empty space cradling every star and every atom is restless and alive and full, trembling with an energy we can feel but cannot explain, hiding a secret about reality that has eluded our very finest minds. Right now, all around you, in the dark of the room and the dark between the stars, the void is gently trembling. The emptiest emptiness there could ever be is quietly humming with the faintest of activity, never fully still, never fully silent, holding the world up softly from beneath. It asks for nothing and explains nothing, and simply is the soft, restless ground of everything. Let that gentle hum of the emptiness hold you now. There is no true silence and no true stillness anywhere, only the faint, endless shimmer of the void, cradling all things including you, as you drift quietly down into sleep. A choice made in the present can seem to reach back and shape what a particle did in the past. To feel the strangeness of this, picture a single particle of light setting out on a journey. It comes to a fork, a place where it might travel along one of two paths to reach a final detector. Now there is a deep and well-tested fact about the small world. If you set things up so that you can tell which path the particle took, it behaves like a simple little speck, choosing one road and traveling quietly along it. But if you set things up so that the two paths blend together at the end, with no way to know which one it followed, the particle behaves like a spread-out wave, somehow traveling both roads at once and rippling against itself when they meet. The way you choose to look decides which face the particle shows you. That much is strange enough, and it has been confirmed countless times. But here a brilliant physicist named John Wheeler asked a question that turns the strangeness inward. What if you wait? What if you let the particle pass the fork first? Let it already be well on its way, committed to its journey, and only then, at the very last instant, decide how you're going to look at it. The particle has already gone by the place where it would have had to choose. If it were going to behave like a single speck on one road, surely it has already done so. If it were going to behave like a wave on both roads, surely that is already underway. The particle cannot know what you will decide because you have not decided yet. So what happens? This was not only a thought. The experiment has actually been done, in careful and ingenious ways, with the choice delayed until after the particle has passed the fork. And the result is the same as ever. When the late choice is made to reveal the path, the particle is found to have behaved like a single speck on one road, as though it had committed to that all along. When the late choice is made to blend the paths, the particle is found to have behaved like a wave on both roads, as though that too had been true from the very start. The particle's past behavior seems to match a decision that was not made until after that past was already over. It is almost as if the present choice reaches gently backward and settles what the particle was doing after the fact. Now, this is the point where we must be careful and honest, because it is easy to leap to a wild conclusion and say that we are changing the past, or sending messages backward through time. Most physicists believe the truth is stranger and subtler than that. The deepest lesson seems to be this: the particle never had a definite story to begin with. Before the measurement, there simply was no hidden fact about which road it took. It is not that the particle secretly chose a path and we later forced it to change. It is that the path was never a settled thing at all, not even to the particle, until the moment the world finally asked. The measurement does not rewrite a fixed history. It is the very act that brings a definite history into being, reaching back to fill in a story that was, until then, genuinely open. Sit with how deeply this unsettles our ordinary sense of time. We tend to imagine the past as a finished thing, carved in stone, complete in every detail, whether or not anyone ever looks. The delayed choice whispers that, down at the smallest scales, this may not be so. That some of what we call the past may remain soft and unsettled, a story not yet fully written until the present moment reaches back and gives it a definite shape. The line between what has happened and what is happening may be far less solid than it feels. We do not fully understand what this means. The mathematics once again predicts every result perfectly, and physicists agree completely on what the experiments will show. But the picture of reality behind it, the true relationship between the present and the past at the very deepest level, remains a quiet and genuine mystery, argued over by thoughtful people to this very day. There is something almost dreamlike in it. In a dream, the past can rearrange itself to fit the present, and you do not notice the seams. The delayed choice hints that the waking world, in its smallest and most hidden workings, may carry a faint echo of that same softness, a place where the present and the past are gently woven together rather than fixed one before the other. So let that strange and gentle thought rest with you now. A single particle of light, far away, its journey not yet quite decided, waiting in a kind of open quiet for the world to look and make it real. Let the past stay soft for a moment. Let this present moment be enough, and drift gently toward sleep. Time does not pass at the same rate for everyone. This is not a feeling or a figure of speech. It is one of the most thoroughly proven facts in all of physics. The faster you move through space, the more slowly time passes for you, compared to someone standing still. And the closer you are to something very heavy, like a planet or a star, the more slowly your time runs as well. Time is not a single steady drumbeat that the whole universe marches to. It is more like a soft and flexible thing, stretching and shrinking depending on how you move and where you happen to be. The differences are far too tiny to notice in everyday life, which is exactly why time feels so absolute to us. But they are real, and we have measured them with exquisite care. Take two perfectly matched clocks ticking in perfect step. Place one on a fast-flying aircraft and send it around the world, and leave the other resting quietly on the ground. When the traveling clock comes home, it will be found to have ticked a little less than the one that stayed behind. Just a tiny fraction of a second, but exactly the amount predicted. The moving clock truly aged less. Time itself ran a little more slowly for it. We rely on this strange truth every single day, often without ever knowing it. High above your head, satellites circle the Earth, helping the small device in your pocket know exactly where you are. Those satellites move quickly, and they sit far from the heavy pull of the Earth, so their clocks run at a slightly different rate than clocks down here on the ground. The difference is small, but if engineers did not carefully account for it, the location on your screen would drift further and further from the truth with every passing hour. The gentle stretching of time is built right into the quiet machinery of modern life. But here's where it grows truly strange and touches the very nature of reality. Because time can run at different rates for different people, the simple idea of now, of this single present moment shared by the whole universe, quietly falls apart. Imagine two events happening far away from each other, two distant flashes of light. To one person, moving in one direction, the two flashes happen at exactly the same instant, perfectly together. But to another person, moving differently, those very same two flashes happen one after the other, with a clear gap between them. And neither person is wrong. There is no master clock, no view from above, that can settle which of them is truly right. They simply have different nows, both equally real, both equally valid. Let that quietly sink in. Your now and the now of a distant traveler need not agree. Two people can disagree about whether two things happened at the same time, and there is no deeper truth that decides between them. The present moment, which feels so solid and so universal, so obviously the same everywhere, turns out to be a local thing, personal to your own motion and your own place in the cosmos. The universe has no single shared instant ticking through all of it at once. It has countless overlapping nows, woven together into something far richer and stranger than the simple flowing present we feel. Some thinkers have followed this idea to a startling place. If there is no universal now, no single moment that the whole universe agrees is the present, then perhaps the past and the future are, in some sense, just as real as this moment. Perhaps all moments simply exist, laid out together in the vast fabric of space and time, and the feeling that only now is real, that the past has vanished and the future has not yet come, is something that belongs to us, to the way our minds travel through the world, rather than to the world itself. This is a real and serious interpretation, debated by physicists and philosophers alike, though it remains a matter of deep argument and not settled fact. We know that time bends and stretches, and that now is not universal. What this finally tells us about the true nature of past, present, and future is still an open and beautiful question. There's a strange comfort hidden in all of this. The moment you are in right now, this quiet moment as you rest, is genuinely your own. It is shaped by your own gentle motion through the universe, your own place among the stars. No one else, anywhere in the cosmos, shares exactly your now. It belongs to you alone. So let your now be soft and unhurried. Let time stretch out gently around you, the way it truly can, slowing and easing as you grow still. There is no master clock you must keep pace with, no single instant rushing the whole universe along. There's only this moment, your moment, quietly your own, as you drift away towards sleep. No one knows whether space can be cut into smaller and smaller pieces forever, or whether it has a smallest possible grain. Think of any small distance, the width of a single hair, then half of that, then half again. In the ordinary world of our imagination, there seems to be no end to this. You can always, in your mind, cut a distance in half and then in half once more, on and on without limit, into ever tinier slivers of space. Space feels perfectly smooth and endlessly divisible, a continuous expanse with no smallest step, like a line you could keep magnifying forever and always find more line waiting. This is how we usually picture the world, and it is how our most successful theory of space and time describes it. A smooth, flowing fabric, divisible without end. But there is good reason to wonder whether this comfortable picture holds all the way down. When physicists combine their deepest ideas about gravity with their deepest ideas about the quantum world of the very small, a curious number emerges. It is a length so unimaginably tiny that it strains the mind to even speak of it. Compared to this length, a single atom is as vast as the whole solar system is to you. And there is reason to think that at this scale, something strange begins to happen to the very idea of distance. The smooth fabric of space may begin to come apart. The notion of a definite ever-shrinking length may stop making sense. Some physicists suspect that this tiny length may be a kind of floor, a smallest meaningful distance, below which the question of where exactly is no longer something the universe can even answer. If that were true, it would mean that space is not the smooth and endless thing it appears to be, but something with a finest possible weave, a texture, almost a faint graininess, far too small for us to ever see directly. Reality at its very deepest level might have something a little like the smallest pieces of a picture, a limit to how finely the world can ever be divided. The continuous flowing space we imagine would then be only how things look from far above. The way a smooth sweep of sand on a beach is really made of countless separate grains when you bring your eye close enough. But, and this is the heart of it, we do not know. This is a genuine and wide-open question. We cannot reach down to that unimaginably tiny scale with any instrument we have, or any instrument we can yet imagine building. To probe such a length directly would take energies so enormous they are utterly beyond us. So we are left in honest uncertainty about one of the most basic features of the world. Is space smooth, divisible forever, with no smallest step? Or is it grainy, woven from tiniest threads, with a true floor beneath all distance? Our finest theories give us hints in both directions, and they do not yet agree, and no experiment has settled it. We simply do not know whether reality at the very bottom is endlessly smooth or finely grained. Pause for a moment over how remarkable that is. You move through space every day. You reach across a room, you feel distances with your whole body, you cross the gentle gaps between things without a second thought. Space is the most familiar thing there is, the very stage on which your whole life unfolds. And yet we do not truly know what it is made of, or whether it is made of anything at all, or whether the smoothness we feel goes all the way down or gives way, far beneath our seeing, to something with a smallest possible step. There's a quiet wonder in holding a question this deep about something this near. The space around you tonight, the soft dark air of the room, the small distance between you and the ceiling, the vast distances out to the stars, all of it may be perfectly smooth, an endless, seamless expanse, or all of it may be woven at a scale far too fine to ever feel, from the tiniest grains of reality, a fabric with the finest possible thread. We do not yet know which world we live in, and somehow that does not trouble the resting body at all. The space around you holds you just the same, smooth or grained, while the question waits, patient and unhurried, for some far-off day. Let that gentle uncertainty settle over you now. The very space that cradles you so familiar and so near, keeping its deepest secret softly, neither smooth nor grained, until we someday learn to ask it properly. Rest within it, whatever it is, and let yourself drift down toward sleep. Ideas dreamed up in quiet rooms, with no thought at all of the stars, keep turning out to describe the universe with uncanny precision. Here is one of the strangest facts about reality, and it is so familiar that we rarely stop to feel how strange it truly is. The universe runs on mathematics. The motions of the planets, the falling of an apple, the flow of heat, the bending of light, the behavior of the very tiniest particles, all of it follows patterns that can be captured in clean and elegant equations. The world is not a chaos. It is deeply, almost suspiciously, mathematical. And the deeper we look, the more mathematical it turns out to be. Now, you might think this is simply because we invented our mathematics to fit the world, like tailoring a coat to a body we could already see. And there is some truth in that. But the truly astonishing thing is how often it happens the other way around. Again and again, mathematicians have explored ideas purely for their own beauty, chasing patterns with no thought of the real world at all, following their curiosity down quiet, abstract paths. And then, sometimes decades or even centuries later, those very ideas turn out to be exactly the language the universe was speaking all along. Consider a strange kind of number that mathematicians once dreamed up almost as a game, a number that seemed to have no place in the real world, treated for a very long time as little more than a curious abstraction. Centuries later, that very idea turned out to lie at the very heart of how the smallest particles behave, woven into the deepest equations of the quantum world. It was as though the universe had been waiting patiently for us to invent the right idea so that we could finally read what was already written. Consider, too, the curved and bending geometries that mathematicians once worked out purely in their imaginations. Geometries of warped and twisted space that seemed to describe nothing real at all. And then, long afterward, those same strange geometries became the perfect language for describing how gravity bends space and time around the stars. Even more wondrous are the times when the mathematics ran ahead of us and pointed to things no one had ever seen. There have been moments when a physicist, simply following the equations where they led, trusting the mathematics over plain intuition, found that the equations insisted on the existence of something entirely unknown, a new kind of particle, a faint ripple in space itself. And when, sometimes many years later, people finally went looking, the unknown thing was truly there, exactly as the mathematics had promised. The equations knew before we did. The universe agreed with the abstract symbols on the page. This is what one great physicist called the unreasonable effectiveness of mathematics. Unreasonable because there is no obvious reason it should work so well. Why should the universe care about the elegant patterns that human minds happen to find beautiful? Why should reality, the hard physical world of matter and energy and space, bend itself so faithfully to the abstract dreams of mathematics, a thing that seems to live in the mind rather than out in the world? Nobody knows. It is one of the deepest and quietest mysteries there is, hiding behind every equation that has ever turned out to be true. And it opens onto an even older question, one that thinkers have turned over for thousands of years. When a mathematician discovers a new truth, are they inventing it, building something new out of the workings of the human mind? Or are they discovering it, uncovering something that was somehow already there, true all along, waiting to be found, as real in its own quiet way as a distant mountain or a hidden star? When we find that a piece of mathematics describes the world, does that mean mathematics is woven into the very fabric of reality, part of what the universe most deeply is? Or is it a reflection of how our own minds are built, a pattern we cannot help but paint across everything we see? These are real and open questions, argued over by brilliant people, and they have no settled answer. There is a deep and gentle wonder in this, It means that when you do a simple sum, or trace a curve, or feel the quiet rightness of a clean and elegant pattern, you may be brushing up against something that runs all the way down to the foundations of reality. The same quiet order that guides the planets in their courses and binds the atoms in your body may be the very order that a child feels when they first sense that numbers fit together just so. The universe and the mind meeting in the language of mathematics, for reasons no one fully understands. So let that quiet mystery rest beside you now. A universe that speaks in elegant patterns and a mind that can somehow read them, woven together in a harmony far deeper than we know how to explain. You do not need to solve it tonight. You only need to feel, softly, the gentle order beneath all things, holding the stars and the atoms and your own resting breath in the same quiet pattern as you drift away towards sleep. When something falls into a black hole, the deepest laws of physics insist it cannot truly vanish, and yet it seems to vanish completely. A black hole is the strangest object in the universe. It is what can remain when a giant star collapses at the end of its long life, crushing itself down under its own immense weight into something so dense that not even light can escape its grip. Around it lies an invisible boundary, a point of no return. Anything that drifts across that boundary, any speck of light, any wandering atom, any object at all, is pulled inexorably inward and can never come back out. From the outside, things simply fall in and are gone, swallowed into a darkness from which no signal ever returns. For a long time, black holes were thought to be perfectly, eternally black. Whatever fell in was lost forever, and the black hole itself would simply sit there, unchanging for all of time. But then a brilliant physicist named Stephen Hawking discovered something that changed everything. Using the strange rules of the quantum world, he showed that black holes are not entirely black after all. They glow, ever so faintly, with a feeble warmth leaking out from just outside their edge. And because they glow, they slowly lose their energy. Over spans of time almost beyond imagining, far longer than the present age of the universe, a black hole will very gradually shrink, fading away, until at last it is gone entirely, evaporated into that faint and patient glow. And here the deep trouble begins. Think of everything that fell into the black hole over its long life. All the matter, all the light, all the intricate detail of whatever it swallowed. In our deepest understanding of the quantum world, there is a sacred principle, almost a law beneath the laws. Information is never truly destroyed. The precise details of how things are arranged may be scrambled beyond all recognition, but in principle they are always preserved, never wholly erased. The story of what a thing was can always, in principle, be traced. But when a black hole slowly evaporates and finally disappears, what becomes of all the information about everything that fell inside? The faint glow that leaks out seems to carry no trace of it, no memory of what was swallowed. And when the black hole is gone, that information appears to be gone with it, erased from reality completely. The black hole seems to break the deepest rule there is. This is the black hole information paradox, and it has troubled the finest minds in physics for half a century. On one side stands our understanding of black holes and gravity, which seems to say the information is lost. On the other stands our understanding of the quantum world, which says information can never be lost. Both have been tested and trusted. Both cannot be wholly right. Something in our deepest picture of reality must give way, and for a very long time no one could see how. In recent years, there has been real and exciting progress, and it is worth being honest about exactly where things stand. Many physicists now believe with growing confidence that the information is not truly lost after all, that it must somehow be subtly encoded in that faint escaping glow, carried out of the black hole in a form so scrambled that we cannot yet read it. Clever new mathematics has begun to suggest how this might work, hinting at deep and surprising connections woven through the very fabric of space. But the full picture is far from settled. Exactly how the information escapes, exactly what happens at the boundary and deep within, exactly how to bring our two great theories into harmony here, remains genuinely unresolved. We sense that the paradox is pointing us toward something profound about the true nature of space and gravity and information itself, but we have not yet fully grasped what it is. There is something quietly humbling in this. A black hole is, in a way, the universe pushed to its most extreme, gravity taken to its very furthest limit, and there, at that edge, two of our deepest truths collide and cannot both stand. The puzzle of what happens to a single speck of light as it falls into the dark turns out to touch the very foundations of reality, and to hint that space and information may be far more deeply entwined than we ever imagined. So picture it gently now. A black hole far across the cosmos, glowing with the faintest imaginable warmth, slowly and patiently releasing back into the universe over unimaginable ages the secrets of everything it ever swallowed. Nothing truly lost, perhaps, only hidden, only scrambled, only waiting in a form we cannot yet read. Let that quiet thought hold you. Even at the darkest edge of all, the universe may forget nothing. Rest in that gentle possibility and let yourself drift towards sleep. Everything inside a region of space may be fully written upon its distant outer surface. This is one of the strangest ideas in all of modern physics, and to feel its strangeness, imagine a great glass sphere with a whole little world inside it. Stars and planets, perhaps, drifting in the space within. Now here's the startling thought. According to a serious and influential idea in physics, everything happening inside that sphere, every star, every motion, every last detail of the three-dimensional world within, could be completely captured by information painted only on the two-dimensional surface of the sphere, the thin skin at its edge. Not a rough sketch or a faded shadow, but a complete and perfect description, holding every last detail of the rich interior, written entirely on the boundary. The inside and its distant surface would be two ways of telling the very same story. If this sounds impossible, you are in good company, for it surprised the very physicists who first stumbled upon it. The idea grew, strangely enough, out of the study of black holes. When physicists worked out how much hidden complexity a black hole can hold, how much information can be swallowed into one, they expected the answer to depend on its volume, on how much room there is inside. The way the number of things you can fit in a box depends on how big the box is. But that is not what they found. The amount of information a black hole can hold turned out to depend instead on its surface area, on the size of its boundary, and not on the space within. It was as though all the information were somehow stored on the surface, spread across the edge, rather than filling the interior. This was a deep and unexpected clue, and it suggested something general and profound. That perhaps, for any region of space at all, the true accounting of everything inside is written upon its surface. From this grew what physicists call the holographic principle. The name comes from those shimmering images we call holograms, flat surfaces that nonetheless contain a full three-dimensional scene, springing into depth when the light catches them, just so. The idea is that reality itself might work in something like this way. That the three-dimensional world we feel all around us, with all its depth and volume and solidity, might in some deep sense be encoded on a distant two-dimensional surface, the way a hologram blooms into depth from a flat sheet. The world you move through, the room around you, the reach of space out to the stars, might be a kind of projection, a rich inner story whose complete telling lives on a faraway boundary. Now, it is very important to be honest and clear about what this is. The holographic principle is a theory, a deep and serious and influential idea, but not a proven fact about our universe. In certain carefully constructed imaginary universes, ones with shapes and rules a little different from our own, physicists have been able to show this idea working with great mathematical precision. A complete world inside perfectly mirrored by a description living on its boundary. These results are real and remarkable, and they have taught us a great deal. But whether our own universe truly works this way, whether our reality is genuinely written on some distant surface, remains an open question, a profound possibility rather than an established truth. It is offered here as one of the most intriguing ideas at the frontier of physics, not as something we know to be so. And yet, even held as a possibility, it stirs something deep. It hints that our sense of the world as solid and three-dimensional, with real depth and real volume, might be a kind of beautiful appearance, and that the deeper truth of reality might live in fewer dimensions than we feel, on a surface we can never reach and have never seen. The very thickness of the world, the realness of space stretching away in every direction, might be, in some sense, a projection from a thinner and more fundamental reality. There is a gentle and dreamlike wonder in holding this thought lightly as the kind of thing we do not yet know. That the depth of the room around you, the distance out to the night sky, the whole rich volume of the world you live in, might be a story whose truest telling lies somewhere far away, on a surface at the edge of everything, shining quietly with the full description of all that is. We do not know if it is so, but it is wondrous even to wonder. So let that soft, strange possibility rest beside you now. A world that feels so solid and so deep, perhaps written all the while on a distant shining edge, like light blooming into depth from a flat and gentle surface. Rest in the rich apparent depth of this quiet moment, whatever its deepest nature, and let yourself drift away towards sleep. We cannot entirely rule out that the reality around us is a kind of vast computation. This is the most speculative thought in our whole gentle wandering, and it must be held the most lightly of all, for there is no evidence whatsoever that it is true. But it is a thought that serious people have taken seriously, and it carries a quiet strangeness worth resting in for a moment as the night grows deep. The idea is simply this: could everything you see and feel, the whole rich world around you, be something like an extraordinarily detailed simulation, a reality computed rather than built, running on some unimaginable machine in a world beyond our own? The reasoning behind it goes something like this, and it is more careful than it might first sound. Imagine a future, perhaps very far away, in which it becomes possible to build computers of almost unthinkable power, Machines so capable that they could simulate entire worlds in perfect detail, complete with beings inside them who feel and think and wonder, never once suspecting that their reality is computed. If such a thing were ever truly possible, the argument goes, then there might one day be a great many such simulated worlds, far more of them than there are original ones, each teeming with minds who believe their world is the true and first reality. And if simulated minds came to vastly outnumber the real ones, then a thinking being, knowing nothing more, might wonder whether the odds favored its own world being one of the many simulations rather than the single original. It is a strange and slippery line of thought, and people argue about every step of it, but it is not foolish and it cannot be easily brushed aside. Now let us be very clear and very honest, because this matters. There is no evidence at all that our world is a simulation. None whatsoever. This is a philosophical possibility, a thought experiment, an idea at the very edge of what can be reasoned about. It is not a scientific finding, and it may be that it never can be one. Some have wondered whether a simulated world might show faint cracks, tiny flaws, or limits in the fabric of reality where the computation showed through, and a few have even gone looking for such things. But nothing of the kind has ever been found, and our reality appears seamless and whole, as deep and as detailed as we have ever been able to probe. The idea remains pure speculation, offered here not as a truth but as a curiosity, a place where physics and imagination brush gently against each other in the dark. And yet there is something worth feeling in it, even held this lightly. For whether or not our world is computed, the deeper question it raises is real and old and beautiful. How do you know that the world around you is truly as it seems? What is it that makes reality real? You have only ever known the world through your senses, through signals gathered by your eyes and ears and skin, and woven together somewhere within you into the rich, seamless experience of being here. You have never touched reality directly, only ever this inner picture of it, painted from within. And so the simulation thought, strange as it is really only the newest version of a question as old as wonder itself, asked by dreamers and thinkers for thousands of years. How can we ever be sure that all of this, is real? Here is the quiet truth that lets the question finally rest. Even if we can never prove with perfect certainty that the world is exactly as it seems, the world remains exactly as warm and as real to you as it has always been. The softness of the pillow beneath your head is still soft. The quiet of the night is still quiet. The slow rhythm of your own breathing is still yours, still steady, still carrying you gently towards sleep. Whatever reality turns out to be, at its deepest and most hidden level, this experience, this very moment, is genuinely and fully here, and so are you, resting within it. So let that final wondering be the softest of all. Perhaps the world is just as solid as it feels. Almost certainly it is. And even if some far stranger truth lies beneath it, one we may never know, it changes nothing at all about the gentle realness of this quiet moment, this breath, this slow drifting down into rest. The mystery can keep. You are here, and that is enough. Let the question dissolve now, like a thought at the very edge of sleep, and let yourself drift gently into the dark. If you are still here with me, still awake in the quiet, then perhaps the wondering has kept you gentle company rather than carried you off. And that is perfectly all right. There is no hurry, and there is nothing you need to do. You might let another of our journeys begin, and drift along on the soft sound of it, wherever it may wander. Or you might simply lie here a little longer, in the soft dark, letting the great gentle mysteries settle around you like stars coming out one by one. For we have wandered tonight through some of the deepest unanswered questions there are, and we leave them all just as we found them, open and quiet and unhurried, waiting patiently in the dark for some far-off day. There is a strange comfort in that. You do not have to understand the universe to belong to it. You are already part of it, woven from its oldest light, resting now beneath its endless sky. So let your thoughts grow soft and slow. Let the questions drift away unanswered, as gently as they came. And wherever your mind may wander as you fall, may it wander somewhere kind. Sweet dreams among the stars.